Hello, Math 3 students. I wanted to show you on lesson 1.4 a few things. And so if you go to your book on page 34, this is where we're at. On the bottom, it will tell you a very important piece of information in this key concept box. And this is where really everything that we're going to do on this lesson is based upon. Let's read this right here. Essential understanding. Many common statistics, such as human height, weight, or blood pressure, gathered from samples in the natural world tend to have a normal distribution about their mean. Remember, mean is average, and the average is found by adding all the data points and dividing by how many there are. The symbol for mean in this textbook is called X bar. And then you will also find another symbol for average, and that's when you are in probability class or you take a lesson on probability, and that is called mu. Mu, so we say mu. How do I write that? Mu. Oh, kind of like that. This is the symbol right here, and that's used in probability for average, okay? And a normal distribution has data that vary randomly from the mean. So that means they're spread out randomly around the average. In the spread, how much of a spread, it's called the standard deviation. The graph of a normal distribution is a normal curve. Sometimes you'll hear the word bell curve because it kind of looks like, I guess, like a bell. I don't know. You know what? I think the man that invented that curve, his name was Bell. You might want to Google that and tell me. So the bell curve right here, or the normal curve, is centered at the mean, which where the average is. The average is always in the middle. And if it's normally distributed, and sometimes it's not, and then we go up 3 standard deviation and down 3 standard deviations. Yeah, it's always the same. 34 plus 34 is 68% of the data lies within 1 standard deviation around the mean, up and down. Yeah, so 60, this is right here. This is what I want you to look at. 68% of data fall within 1 standard deviation of the mean, up plus 1 standard deviation, down 1 standard deviation. So whatever the average is, you can add 1 and subtract 1, and 68% of the data is right here. I'm just going to shade that in, right? Whatever the numbers are, almost 70% are going to be right here if it's distributed normally. Then within 2 standards, you add another 13.5% on each wing. So 13.5 plus 13.5 makes it 27%. So 27% added to 68 will give you 95% of data fall within 2 standard deviation of the mean. So from here to here is 95%. Almost all of the data points will fall in this range right here. Okay, and then the little tail at the end contains on each side the 3rd standard deviation, adding 3 and subtracting 3, and that's this part right here. This little part right here is 2.35% on each side. Do you see how you have it on each side? Well, if you add that together, 2.35 plus 13.5 plus 34 plus 34 plus 13.5. So 99.7% of all data fall within 3 standard deviations of the average around the mean. So 99.7% Okay, well, you're saying where's the rest? Why is it not 100%? There's 0.3% left. The 0.3% are divided in these two tails. The very little end right here, if you notice, the 3 standard deviations only go so far. Notice the curve still continues, right? A little bit. And so this little tail right here lies outside of the 3 standard deviation. That is the difference to 100%. 0.03% lie outside of 3 standard deviations. So did I do this right? Yeah, 3%, 0.03. Wait a minute, let me make sure I added that correctly. 99.7. So let me do this. 100 minus 99.7. Oh, I have a little bit too many numbers here. So I'm going to fix that right here. Make sure we fix it. It's not 0.03, it's only 0.3%. So a very small fraction, and you got to split that up on both tails. These are called tails. And here also. Okay, so this right here would be 0.15%, and this would be 0.15% as well, because it's half and half. It's exactly always half on each side if our distribution is normal, if we have a normal curve. Some of the curves, so again, I want you to look at these numbers. These numbers you're going to use in your IXL assignment that I gave you with this lesson. 68% as a decimal is 0 on the IXL assignment. It's talking about probability, and they want the answers in decimal form. So you need to answer in this version. Yeah, so the decimal form and the percent. In probability, we use the decimal form of the percentage. Probability will ask you, what is the probability that a data point lies within 1 standard deviation? And then you would have to answer from this chart using the decimal. And I'm giving you examples from your IXL, okay? So this is an important page. And then here are not normal. Sometimes data are not normally distributed, okay? That's called skewed. You might have, they call it, this book uses a little bit different verbiage than what I'm used to. The tail longer to the right. I have seen textbook, they call this right skewed and this left skewed, but this book calls it positively skewed and negatively skewed. So the data that we're using is normally distributed. If it's not, the lesson really doesn't apply, but we want you to know that it's not always normally distributed. So on this, there's a couple, the homework questions I assigned to you are on page 36, and it's the practice on top with the biology. So you're going to do the number 1, 2, and 3 after you look at your lesson on Savas Realize, or while you're doing it. Then we have, this one actually is on, this one they show you actually on Savas, the very same problem with the eel, the fish, the body length and the standard deviation. And so you can actually just copy that from your lesson. And then on the next page, we're on page 37. This is kind of backwards. The book opened weird on this platform. You're going to do number 4. So this is page 37, number 4 and number 5. And remember, we always will go over every question in class that you have done for homework so you can check and make sure you get it. But I want you to try it. And then problem 3. A and B. And then 2 more questions on the next page. That's page 38 now we're on. Yep, page 38. And you will do number 9. And vocabulary number 11. So that's from the textbook and from your Savvas. And then I have an IXL assignment for you. And the IXL is in the Algebra 2 tab. And it's EE11, double E11. That's kind of at the end. Find probabilities using the normal distribution. So the probability is, it works out the same way. Trying to fix my little pen. So the question says X is a normally distributed random variable. So that's just a number in our data set. And we have a normal distribution, so we can use our little bell curve I have showed you on that first page. That's super important to use that. X is a normally distributed random variable. So any number, the average is 47. So you need that. And a standard deviation of 19. So they always give you the standard deviation. You never have to find it. So I'm going to draw a bell curve. And so you always start out making this kind of a bell curve. The middle is always a straight line with the average. And remember, we're going how many standard deviations in each direction? 3, right? So this is your first, second, third. So I'm gonna make a different color for this so you see it. Sorry about my marker. Not always perfect. So 3 standard deviations in each direction. First, second, third, first, second, third. So you can always kind of draw yourself this picture. And the standard deviation is 19. So you're going up 19 and down 19. So 47 plus 19. And 47 minus 19 is your first data. 47 plus 19. So we're going up to 66. So there's 66 and 47 minus 19. And we're going down to 28. And then I'm going to go up another 19. So 66 plus 19 is 85. 28 minus 19 is 9. And I'm going to stop here because I already see that I'm covering the numbers they want me to check. See how it says, what is the probability that our data point X is between 9 and 85? So we have plus 1 standard deviation, plus 2 standard deviation, minus 1, minus 2. So we're looking for this area here under the curve. It's actually the area under this curve that we're looking for. Okay, and now if you go back to your, so we're looking up and down 2 standard deviations. If you go back to your first page and look, so we have 95% of data fall within 2 standard deviation of the average or mean. Okay, so 95% is my answer. Okay, all right. What is the probability that our data point is between 9 and 85? Now remember, it's 95%. And 95% is 0.95 in probability. So that would be your answer right here. And submit. Okay. And if you have an answer that's more than 2 decimals, you need to use up to 3. It says to the nearest thousands. That means this is the hundredth, and that means one more number. That's if you're in the tail. Or if you have 3 standard deviations, it goes up to a higher number. Okay, so that's how that works. And then the last question for this little video is another question on this IXL assignment. It says here, X is a normally distributed random variable. It means it's just a data point, and that our data is normally distributed. You can use a normal curve or bell curve. The average is 46. And we have a standard deviation of 15. What is the probability that you pick a data point and you happen to pick less than 16? Okay, so again, let's make a bell curve. Middle is your average. And you're going up and down up to 3 standard deviations. That's as much as we go. Okay, each deviation is 15. So, but we want to find out what is the probability X is less than 16. So we don't need to go up, we need to go down. So I'm going to draw -1, -2, -3 deviation. -1, -2, let's see, 46 minus, I think it's just 2 because 2 times 15 is 30, and that looks like, so I'm moving 2 standard deviations, 46 minus, oh no, not 30, 15, 2 standard deviations. It's 16. Notice I go down 2, right? So this is where I'm ending up. So that one would be 15, 46, 31, I believe. 46 minus 15 is 31, and then here. So we want to know what is the probability it's less than 16. So less than 16 will be in this part right here. Yeah, this is the tail that's left, correct? Okay, so back to that first page, and let's look where we're at. I'm going to erase what we got. Darn it, I keep erasing my little toolbar. I'm going to erase what we have here so we don't get confused. So we are 2 standard deviations from the mean, from the average. So here's your average, and we went down 1, 2. So we have this little area here, this little tail, we got to have it covered, right? So I'm looking, 95% of data fall within 2 standard deviations. So that would be this side of the tail. Now we want the opposite side. So you have to think kind of the opposite. If 95% of the data fall in this area that I'm circling here, then 5% must fall in the tails. That leaves 5% for both tails, right? And because we only want this right here, less than 16 degrees, I mean 16, not degrees, I'm sorry, less than 16 is our cutoff. We need to only have this part right here, not that up here. Well, both together are 5%, but it's symmetric. The bell curve is symmetric. So we're going to divide that by 2, and we get 0.25% for this tail right here, half of the total. So it all starts here. 95% are here. That means the rest, 5%, are in the tails, but we only want half of the tail. So 5% divided by 2 is, did I do that right? 5 divided by 2, 2.5%. I keep doing that. 2.5%. And when you enter that in the computer, they want the probability. You need to move your decimal 2 spaces. So you will enter 0.025. So back to our question. What's the probability that our number that we just picked at random is in this part of our bell curve? It was 0.025. And that's your 3, because that's as high as you'll go, nearest thousands, and submit. All right, I'm going to give you this, and it's it's tricky, especially when you come upon questions like that, where you have to think, well, it's kind of backwards in a sense, but hopefully you will take advantage of tutoring hours, ask me in class, and hope 80% minimum is what I require for IXL assignments. That's a B, okay? But if you get higher, that's an A. If you get into the 90s, obviously that would be an A. All right, talk to you soon.